Welcome to the channel. Today we are looking at how environmental conditions can affect CMM accuracy and why even a highly advanced machine can produce unreliable results when the surrounding environment is not properly controlled. What are CMM accuracy factors? CMM accuracy factors are the environmental and operational conditions that influence how precisely a coordinate measuring machine performs. These factors include temperature, humidity, vibration, airflow, contamination, and even how operators handle parts during inspection. Why is temperature one of the most important CMM accuracy factors? Temperature affects both the machine and the part being measured. When temperatures change, materials expand or contract, which can make a part appear slightly larger or smaller than it truly is under stable reference conditions. What happens when a workpiece has not stabilized to room conditions? If a part comes from machining, storage, or shipping areas with a different temperature, it may not yet reflect its true dimensions in the inspection environment. Measuring too soon can capture temperature-related distortion instead of actual geometry. Can temperature also affect the CMM itself? Yes. The CMM structure, scales, guideways, and probe system can all respond to temperature changes. If different parts of the machine warm or cool unevenly, repeatability and overall measurement accuracy can suffer. How does humidity influence CMM performance? Humidity can affect long-term machine stability by increasing the risk of corrosion, condensation, and wear on sensitive components. It can also influence certain non-metallic materials during measurement, making stable humidity an important part of inspection control. Can vibration interfere with CMM measurements? Yes. Vibration from nearby machinery, foot traffic, forklifts, unstable flooring, or even passing vehicles can disrupt probing and reduce repeatability. When that happens, the machine may capture unstable or inconsistent point data. Why does airflow matter in a CMM inspection area? Airflow can create drafts and localize temperature changes around both the CMM and the workpiece. That may lead to unexpected variation, especially if vents, fans, windows, or open doors are affecting the inspection area throughout the day. How can dust and contamination affect measurement results? Dust, oil mist, and debris can settle on the part, fixture, probe, or machine surfaces. When that happens, the CMM may measure contamination instead of the true surface, which can shift point locations and reduce confidence in the result. Do part size, material type, and human activity also play a role? Yes. Larger parts often take longer to stabilize to room conditions, and different materials respond differently to temperature and moisture. Human activity also matters because opening doors, moving parts between temperature zones, and inconsistent handling practices can all affect inspection conditions. What practical steps help reduce environmental measurement risk? Practical improvements include maintaining stable temperature, allowing parts to acclimate, limiting vibration exposure, controlling airflow, keeping the area clean, managing humidity, and training operators to understand how environmental conditions affect results. Is calibration alone enough to guarantee accurate CMM results? No. Calibration is essential, but it is only part of the picture. Even a calibrated CMM can produce inconsistent results if the surrounding environment is unstable. Hurka Metrology helps manufacturers support measurement accuracy through calibration expertise and practical guidance. Visit www.fdhurka.com to learn more.